This is an ideal situation. Balanced line, clear demand, same rate of production, a transfer batch size equal to approximately 1 hour of production, inventory is low, all on time. However, not many have this liberty of having a balanced line. And one of the things we tried to mention was, do not balance the line, balance the flow. So let's look at a situation where we have a constraint. That means the rate of production is at the end. That means the finishing stage has a rate of production which is lesser than everybody. That let's put that as 10. The moment we put a rate of production which is less, we are working on a pull system. It says that you should have started on the 15th of August. Now, a drop in rate of production certainly makes the plan unfeasible. So let's push again. Oops. If the constraint is towards the end of the operation, we push. Yes, we do have our orders going out late, but we also have a high inventory. Let's go back and check again. I was pulling. My inventory levels were low, but it was telling me that please start on 15th of August, while today is 19th of August. This is not possible. So when I push, that means I start planning from today into the future. I not only have missed due dates, which was but expected. What is surprising is the inventory in the system is very high. This is what we meant by saying that when you avoid buildup of unneeded queues at less constrained operations, the work will flow at high speed. And this is what is not being done. There is no practical mechanism for avoiding this buildup of inventory or overproduction, as it may be interpreted normally. So we have a situation where we don't have a mechanism to limit overproduction. We have a constraint towards the end, which not only is now delaying the production, but also spiking my inventory. This is what happens in push. But what we have repeatedly put out is one of the bigger factors driving this kind of a behavior is machine utilization. That means if the upstream machines have enough available capacity, it is but natural for our efficiency driven management to make sure they are working. And if they are working, naturally they are consuming the raw materials and increasing WIP, where this WIP gets piled up towards the end of the production line or at the downstream stages of production. And that happens because they have lesser capacity. Mind you, what happens if the first stage of operation has much higher capacity and you're pushing, what will happen? Naturally, the WIP will go through the roof. Let me go back and put 15 again and see. What we were seeing was the peak inventory of 180 till the order was satisfied and pushed out of the shop floor. But in case the rate of production of the first stage is higher, we see the buildup of inventory is much higher. And who is going to stand and say that please don't utilize this machine to 100%? The utilization measurement, which is so prevalent in our manufacturing organizations, pushes in a behavior like this. It is the first operation and it's got a high capacity. It is going to be a real tough task to convince your bosses that no, I am not going to produce more than what is required down the line. Because down the line figures are 100% because they're already a constrained resource. Since they're constrained resource, every day they have a load which is practically 100% to their available capacity. But if those numbers were also to be produced by the machine, that means the first stage manufacturing machine, the efficiency figures would be less. And hence, it would be tough to stop the machine from working or to make the machine work just enough so that the machine down the line doesn't starve. The material never runs out, but this machine only produces what is required down the stream. That means stage number 1 machine would be working and stopping, working and stopping. Now, let's reverse. Let us say the first operation is a constraint. The orders are late. Again, the 2 orders are late. I'm still pushing. And if orders are late and I pull, definitely I'm going to get an infeasible solution. But my inventories have gone down. So the location of the constraint is deciding whether the push way of planning or the pull way of planning is going to be more efficient. This is another example to say that only when you have understood the assumptions of your environment should you design your planning and execution systems. However, in this example, what we are trying to bring across is if the flow of material is very high, the chances are that WIP in the system will be less. And while this WIP is less, you are also seeing that the due date performance of your orders is also pretty high. Now, we have also realized that it is the rate of production of the slowest machine which is deciding the throughput of the system and also the inventory within the system. So let us see what would have happened if the constraint was in the middle. Same figures. same performance. Let us say push will work or pull will work. Pull gives an infeasible solution. However, let's try one more thing. Let us increase the difference in capacity. We have increased the difference in capacity and the inventory levels have gone up. That means more and more of items have been produced by the first machine and pushed into the system. This happens because the machine is able to process the same number of units at a much faster rate and then sits idle. So if one has to maintain an even inventory within the system, you have to limit the production of the first machine.